All right, I know this seems out of order, but the next section we're going to learn is actually section 5.4. So you're going to jump ahead to the Unit 5 section of your workbook, and that's on page 227, 5-4. And it's because it's still talking about triangle relationships. This section should actually probably fall in topic 4. It just, for some reason, doesn't, but we're going to learn it with our triangle relationships. And it's about inequalities in a triangle and truly just how a triangle is formed and what we must know about their side lengths. So on your Explore and Reason page, I want you to pause and jot down our two theorems that we see here. Theorem 5.9 and the converse of it real quick. Okay, it's essentially saying that the larger side is opposite of the longest angle and so forth. So if angle A is the largest angle, then side A is the largest side. Or if side B is the largest side, then angle B is the largest angle. Those go together. The next big idea of this section is the triangle inequality theorem. And I'm just going to talk through this while you guys jot it down. It pretty much is saying that the two shorter sides of a triangle have to add to be greater than that longer third side, that hypotenuse side. Like if we were thinking of a right triangle, the larger side. And we're going to dive more into that here in a couple examples. So let's actually turn the page and we're going to skip example 1 and go straight to example 2. Example 2 is having us use Theorem 5.9, which was about that the larger angle lies across the larger side. And so we have our little sketch here that Lucas sketched a diagram for a garden box. And we can see that we have 3 given side lengths, 10, 14, and 8. And it says, part A says which angle is the largest. Using that theorem, we're learning that the largest angle is across from the largest side. So the largest side here would be that 14. So the angle across from that is angle E. So for A, we would literally just say that's angle E. Okay, to do part B. Part B. Which angle is the smallest? Well, the smallest angle is across from the smallest side. So our smallest side is this 8 inches. The angle across from that is angle D. That's just to practice us figuring out what those theorems meant. So now let's do the converse of it, which is where we flip it around. We do like almost the opposite, the reverse. In example 4, we're going to use the converse and to figure out now which sides are the longest. So in this example, we knew the side lengths, we didn't know the angles. Here we know the angles and we don't know the side lengths. But before we start comparing the side lengths, we should find that missing angle so we have all of our information and we can make an accurate decision. So if you guys see that we have an angle measure of 65 degrees and an angle measure of 58 degrees, if we add those up and subtract them from 180 degrees, we can find that our missing side is 57 degrees. And we should know that because now we can make an accurate decision about what is our largest side and what is our smallest side. We don't have any unknowns. Okay, so which side is the largest or the longest? Well, that is opposite of our largest angle. So if our largest angle is this 65 degrees, then the longest side is OP. And we're going to write that alphabetically. I wouldn't write PO. We want to keep that in alphabetical order when we're talking about the lengths. And if we wanted to find the shortest, well, that's going to be across from our smallest angle. So out of the 3, the smallest angle is this 57 degrees. The side across from that is side NP. Just like that. If you can find the largest or the shortest side or angle, you can find the corresponding part. Now our very last example is using that triangle inequality theorem, which off to the side, you should take some written notes with me. That in basic terms, the triangle inequality theorem tells us that the two shorter sides have to add together and be larger than the longest side in order for our three sides to actually form a triangle. An example that we would do in person is if I had two short sides and then one really long side, they wouldn't connect. So these two together have to be longer than this one in order for us to actually be able to create a triangle. And I've kind of put it out for you in an inequality like equation term that 1 plus 2 being the two shorter have to be greater than the longest one. So 5a says, could a triangle have side lengths of 16, 39, and 28 meters? And so that's asking us like, hey, can this actually be a triangle? And we're learning through this triangle inequality theorem that, okay, if this can be a triangle, then the two shorter sides have to be longer than the third. So we've got three sides. I'm going to put them in order. That's 16, 28, and 39. So in order for this to actually be a triangle, the two shorter sides, 16 plus 28, has to be greater than 44. Let's figure it out. Shoot, not 44. It's 39. Oops. 39. Okay, well, spoiler alert. 16 plus 28 is 44. So 44 greater than 39? Yes, it is. So yes, this can be a triangle. A triangle could be created with those side lengths. If it was not greater than 39, then our answer would be no. You can't actually make a triangle with these side lengths. They would not connect. You wouldn't be able to connect all of the vertices. Let's apply this theorem to 5b, and I'm going to scroll down and kind of zoom in. It says a triangle has side lengths that are 30 inches and 50 inches. What are the possible lengths of the third side? So we don't know what that third side is, but using what we just learned, we can figure out the range of what it could be. So what I've done is I've sketched a little triangle. Now I don't know the third side, so I left it dotted. Here we don't know, you dude. I've used an X to represent what I don't know. But I do know that I have two sides that are 30 inches and 50 inches. So the option for this third side, we've got two routes here. Either 50, the 50-inch side, is the longest side, or it's not, and that means that the unknown side is the longest side. And that's what we're going to base this on, is either the 50-inch side is longest or our unknown is longest. So let's put ourselves in the mode that the 50-inch side is the longest, which means the two shorter sides would be 30 and the unknown. So we would have 30 plus our unknown has to be greater than 50. If 50 is the longest side, because the two shorters must be greater than the longer. So if we were to solve that really quick, that means that our unknown side has to be greater than 20 inches, if I subtract that 30. So we know we have to be greater than 20 for 50 to be the longest side. Well, let's think about if our unknown side is the longest side. That means that 30 and 50 are the two shorter sides. So we would have 30 plus 50 has to be greater than our unknown. Because in this case, the largest is that unknown side. So if we add 30 and 50, that's 80 has to be greater than that unknown. And if I want to write this as a range, remember you can reverse your inequality, and I can put it, it's the same thing as x is less than 80. And now I can write this as a range of between 20 and 80. So in order for this to be a triangle, we have to be between 20 and 80 inches. So 20 is less than x is less than 80 is how we write those compound inequalities, if you remember from Algebra 1, where the inequality sign has to go the same direction. That'd be the same as 20 is less than x. We just flip it around. So in order for this to be a triangle, we have to have this unknown side length be between 20 and 80 inches. If it's outside of that range, then it would not be a triangle. And that's the way you would approach questions like this, is think, okay, is what I know that's the largest right now, is that actually the largest? Okay, then this has to be greater than 20. Okay, what if the x is the largest side? Oh, okay, then these have to add to be, it has to be greater than or less than 80. All right, and that's 5.4.